Hi everybody, my name is Alan Herman. I'm going to talk a little bit about how React works and a little bit about how to optimize your apps for some speed. We've all been using React for a couple months now, and I know you guys are all experts at writing components and connecting them to a store and all that, but you might be wondering what's going on behind the scenes, and that's what I'm going to talk about. So it's pretty simple. Really what's going on behind the scenes is that Gandalf is really kind of helping you out there. So I'm going to talk a little bit about these different components here, so I'll give you an idea of what I'm going to go over today. But first of all, I want to say that React has a virtual DOM, and it's also manipulating the browser's DOM. So I just want to make sure you guys are all aware that if I say virtual DOM, that's React's DOM, browser DOM, or if I just say DOM by accident, I'm talking about the browser. So first, React is what's called a model view controller. It's the architecture of the library. What that really means is that it splits up the control of the whole process into three components: a model, a view, and a controller. The model manages the data and the rules. That's really your React components, the stuff that's going on behind the render and state and stuff. The view is what the user sees that ends up getting put out on the browser's DOM, controlled by the render function in your components. And the controller is what receives input from the user. So it'd be click events or API requests might also modify your model. So that's just a little view there of what's going on. They're all just kind of going in a circle right there. So sometimes in some MVC setups, the controller can also modify the browser or DOM directly. React is set up so that doesn't happen. So the virtual DOM, that's React's JavaScript object that is a representation of how the actual browser DOM is supposed to look. It is a JavaScript object. It's extremely fast compared to the actual browser DOM. It can produce somewhere around 200,000 virtual DOM nodes per second. So unless your app is ridiculously large, you should not have any load time problems because of that. And the interesting thing is it's so fast that they create it completely from scratch every time. So if anything changes in your app, it'll create a whole new virtual DOM from everything. So not just what changed, is literally everything gets created from scratch. This is an example. You guys have all probably seen this. I'm sorry it's a little small, but this is just a screenshot of the virtual DOM that the DevTools gives us from my little baseball app there. And I can actually show you a little bit. I was able to go into the React library, the node module, and I found a little area where I can console log what's going on there. And that actually produces the node elements on the virtual DOM. So you can actually look at what is going on underneath the covers. So this isn't the actual virtual DOM. These are the nodes for each element of the DOM. You can open them up and kind of see what they are. You can see type, div, button, image down there. And so that's what React is actually using behind the scenes to compare one DOM, the old DOM, to the new DOM. So the diffing algorithm is what React uses to compare the two DOMs. So it has an old DOM, which is what you were using, and then something changes on your app, it creates a whole new virtual DOM, and then it has to go in and compare those two and find the differences. Now, it uses these two assumptions, and these two assumptions are actually what makes React so cool. Two elements of different types will produce different trees, and the developer can use the keys, which we are all familiar with because of the various warnings we get, to kind of tell React what might be stable across two DOMs. And this is great because if you are going to reorder a set of sibling nodes, then React will keep those instances of nodes instead of creating them from scratch. So this is one of the things that helps make React so fast. So another example here, these are straight off the React website. So in this instance, the div and the span are two different things. So it will actually unmount, destroy the counter and create a new one. This is what you don't want because this is relatively slow. So if you want to keep your app fast, keep this in mind. If you're changing a type and it has nodes going down the tree, but the type doesn't need to change, you kind of want to try and keep it the same. So if the types are the same, but the attributes or props are different, it will change the attributes or props, but it will keep the instance the same. So there's another thing that makes it fast, and the style tag will also do the same thing. So it does not get rid of the DOM node, but it just changes the properties of it very quickly. So this is a little bit about the diffing algorithm more. A truly minimal difference can be calculated O n cubed, big O n cubed, which, as you can imagine, is pretty slow. If you have 100 nodes, that's, I think, 1 million operations, which is way too much because 100 nodes on the browser is really not that much. So React uses those enhancements to make their algorithm closer to O constant n, which is pretty fast. So the trick is that if the node's different, it will re-render the entire subtree. And it completely ignores what else is going on down there. So here's so it does breadth first, and that's an example of that is here. So if it were to use a depth first algorithm, what you can see here is that 2a and 4a are the ones that changed. If it went depth first, it would put 4a on the update list and then 2a. So if it ran 4a and then updated 2a, well, you just did this for no reason. So that's one of the things that keeps it fast. So here's the breadth first example. This adds 2a to the update list and then moves on. So React is going level by level looking for changes. In this case, it updates the entire subtree and completely ignores the difference in 4a. It knows it's there in the sense that when it re-renders, it'll be different, but it doesn't traverse it on the diffing algorithm, which is one of the things that keeps React so fast. Okay, now this is how a little bit about how React updates the actual browser DOM. So it creates a new DOM, it diffs it versus the new one, and then it creates a list of the minimum possible differences to change the browser DOM to what it's supposed to look like. Once it completes the list, it'll fire off all the changes in rapid succession, no read files, all write files. And the reason they do this is because sometimes in the browser, if you read from the DOM, then it'll create a reflow event. And a reflow event is the browser recalculates the positions and colors and geometries of everything on the screen, which, as you might imagine, is extremely slow. So React does everything it can to avoid these events, and it only does it once at the end, once all the updates are taken care of, and that's... Okay, so shouldComponentUpdate is a tool that React gives us in order to avoid updating a component that isn't changing. So if this component were in the bottom of that subtree, that 4a that I was talking about earlier, you could use the shouldComponentUpdate lifecycle hook in order to keep it from re-rendering. So it's really just a true-false. You return false, and it'll stop the update. I kind of have an example of that I will show you in a second. So, and then the other thing that I want to talk about more in the optimization realm is the performance tools, which are an add-on from React. You can start and stop at any given moment in your component. And then you can print the measurements using this function right here. And all of these are actually similar to this. They grab this measurement and they print them on the console in a table, so it's easy to read. And that I can also show you. So here in my baseball app again, I have the start here, and then all of these. So what this is doing is on the click, it starts the measurement, goes through the dispatches, and then it stops it after the component updates. Right after it stops it, it prints all this stuff on the console. So actually, let me... So nothing happened yet, but on the click event, it'll print out these tables that give you an idea of how fast everything in your app is rendering and what's going on, more importantly. because sometimes something happens and you don't really know what's happening until you use this. And I think the most important of these tables, really there I'll just, how much time it took to render, and then this is an operation. This is the most important one. This is called the wasted table. So you can see here that this component was re-rendered, but nothing changed. So it was just wasted space. So when I found this out, just kind of studying what this was, I found that the shouldComponentUpdate, so here if we can return false, and this, because this is an update, a shouldComponentUpdate, it won't run, but it will mount the first time because that's not an update. So we can go back here and refresh it, and then to our click event, and now there's no wasted renderings. So this is one thing, one tool you can use to make your app a lot faster. You can find wasted energy in your app and kind of get rid of it. So I hope you guys will use these tools. Hope you have a better understanding of what's going on behind the curtains. And thank you very much.